As heat pumps and their connected pipework are installed outside, it's important that the central heating water circuits are protected from freezing. There are a number of methods and options to achieve this, and in this video we will cover automatic defrost cycle, antifreeze valves, glycol and pipework insulation. Heat pumps will protect themselves from freezing using their control system. When temperature sensors detect low temperatures nearing freezing, they will put themselves into the defrost cycle, drawing available heat from the system within the property. In normal operating conditions, this is enough to prevent freezing. However, in the event of freezing temperatures combined with a power outage, the heat pump will not be able to detect or react to this issue. This combined event can be considered low risk, but it is possible. The risk increases when units are fitted to properties with prepayment meters where interruption to the electric supply may be more frequent. In the event of the outdoor unit freezing, this can cause significant and expensive damage that would not be covered under a manufacturer's warranty, so we need to look at options to protect against it. One option is to install antifreeze valves. They are a mechanical fitting designed to discharge when the system water temperature drops to 3 degrees C, preventing ice from forming in the heat pump circuit. They are fitted to the low point of the primary pipework directly alongside the heat pump. The valve would operate as a last resort, dropping water and pressure out of the system so ice expansion doesn't cause damage to the components and seals. This method is relatively low cost and very simple. The disadvantage being, in event of operation, the system would require repressurising with system water and any associated chemicals such as inhibitor. Therefore, most likely require an engineer visit. It should be stressed, however, given that both a temperature below 3 degrees and a power failure to the unit would be required, operation should be very rare and require investigation if occurring on a frequent basis. They should be installed vertically with the discharge outlet facing downwards to allow water to drain easily. A common recommendation includes leaving a minimum 15 cm gap from the bottom of the discharge pipe to the ground. Also, a minimum of 10 cm between each valve to prevent water from the higher valve discharging onto the lower one. These valves should be fully insulated, leaving the discharge point and vacuum breaker free. The second option is adding a substance called glycol into the system water. Glycol serves as an antifreeze agent, lowering the freezing point of water. Adding a certain percentage of glycol to the central heating water will decrease its freezing point. Glycol manufacturers may recommend varying percentages for mixing with central heating water. A common ratio is 25% glycol to 75% water. The size of the system and its volume will dictate the amount of glycol you need to add to achieve these percentages. If glycol is utilised as the freeze prevention method, the annual service of a heat pump should incorporate a glycol level check within the system. If the glycol level has dropped below the required amount, a top-up would be necessary. Glycol increases the viscosity of water. In basic terms, it makes the water a bit thicker. It also reduces the water's ability to carry heat. So if glycol is to be used, it must be factored in at the design stage, as it could lead to increased pipe sizes being required. It's also very important to properly insulate the primary pipework on a heat pump, particularly as sections of it will be outdoors. The heat pump's energy should be efficiently directed into the heating system. Allowing heat to escape from poor or uninsulated pipework is counterproductive and will result in higher running costs and poor heating performance. Aim to keep the external runs of primary pipework as short as practically possible. This factor should be considered when planning the installation position of the outdoor unit. Exterior insulation used must be Class O type, UV stable and weatherproof. All joints should be fully sealed with a UV protected material, including through the fabric of the wall entering the building. The insulation should cover both the pipework and any integrated valves. There are options available that offer complete coverage for the valve whilst ensuring the handle remains accessible for the necessary use. It's advisable to install all levered valves with the handle facing downwards to prevent rainwater ingress. When securing the insulation, ensure the wall clips are placed over the insulation without compressing it, as this can create gaps which will lead to heat loss. And for this reason, it's advisable to not use cable ties. Additional protection can be provided by fitting trunking over the fully insulated pipes. This helps with the negative effects the weather can have on insulation, which may need a protective coat applying throughout its lifespan. The use of trunking may reduce the frequency of this application.